In Henry's law, partial pressure of gas above the surface of liquid is equal to kH into X. kH means Henry's law constant. So X is mole fraction of gas in the solution. This kH is a function of temperature. kH increases with increase in temperature. As temperature increases, the value of Henry's law constant also increases, and it's a measure of solubility of gas in the liquid. As the value of kH increases, the mole fraction of gas, that is solubility, decreases. As kH increases, as the denominator increases, X, the solubility of gas in the liquid, decreases. You know, kH is a function of temperature. As temperature increases, kH increases, X decreases. Or you can say, as temperature increases, solubility of gas in the liquid decreases. Temperature increases, solubility decreases. Next, you can draw a graph of mole fraction of HCl gas in cyclohexane. So since P is directly proportional to X, you will get a linear graph. You will get a straight line here. This is the graph. Partial pressure in terms of torque versus mole fraction of HCl in cyclohexane solvent. So this is about Henry's law. Next, the applications of Henry's law. What are the applications of Henry's law? This is very important for your theory exam for 3 marks. So write the applications of Henry's law. The first application, it's very simple. To increase the solubility of CO2 in soft drinks or in soda water, bottles are sealed under high pressure. The solubility of CO2 is usually less in water. It is insoluble at normal pressure. So now, in order to increase the solubility of CO2 or to prepare carbonated drinks, we have to dissolve CO2, excess CO2 in water. So in order to dissolve CO2 in water, we have to apply pressure. So after applying the pressure, the bottles are sealed under high pressure. So when you open the bottles, soft drink bottles or soda water, suddenly CO2 gas comes out in the form of bubbles. That's why that soft drink or soda water fizzes out. So this is the first application. To increase the solubility of CO2 in soft drinks or in soda water, bottles are sealed under high pressure. The second application of Henry's law is, in order to avoid bend, air tanks carried by scuba divers are filled with air diluted with helium, nitrogen and oxygen. So now what is this bend? Normally scuba divers, they carry air tanks along with them, scuba divers or sea divers. They carry air tanks. This air tank is filled with air which has oxygen, nitrogen and traces of some other gases. As they go down the sea, as they move deep into the sea, pressure increases. Under deep water, pressure is high, pressure increases. Under deep sea, pressure increases. At this high pressure, solubility of gases which are present in this air tank in blood increases. Solubility of gases in blood increases. Gases means oxygen, nitrogen, all other gases. The solubility of all the gases present in air tank in the blood increases. So now when they come up from the sea, when they come to the surface of water, pressure decreases. When they come up from sea, pressure decreases. Due to decrease in pressure, solubility of gases in blood decreases. So gases comes out from the blood and they form bubbles in blood capillaries. So this serious medical condition is known as bend. So this bend is created by what? Created by these gases which gets readily dissolved in blood at high pressure. So in order to avoid this bend, especially the bend is due to the presence of excess nitrogen. Its mole fraction in air is high. The most of the air contains nitrogen gas. So in order to avoid this bend, what we have to do? We have to decrease the mole fraction or concentration of nitrogen in gas. How? By diluting that air tank or gas with helium. Helium is less soluble in blood, or it is not going to dissolve in blood. Okay, it's insoluble, completely insoluble in blood. So what happens to mole fraction? It reduces to 56.2%, or its percentage reduces to 56.2. So in turns, it decreases its solubility in blood. So this is the second application. So now you got what is bend. You understood what is bend. Bend is because of what? Increase in the solubility of gases along with oxygen in our blood. So when pressure reduces, when scuba divers or sea divers comes up from the sea or from deep water, what happens to the pressure? Pressure decreases. Due to decrease in pressure, solubility of gases also decreases. So when the gas comes out from the blood, it blocks the capillaries, or it forms bubbles in blood capillaries, which causes a serious medical condition which is known as bend. Okay, so in order to avoid bend, we have to decrease the mole fraction of nitrogen in our blood. The bend is mainly due to the presence of nitrogen, not due to oxygen. Oxygen is very much necessary for our blood or to our tissues. Next, the third application is at higher altitudes, partial pressure of oxygen is less than the ground level. As you move away from sea, pressure decreases. So due to that decrease in pressure, solubility of O2 in blood decreases. At higher altitudes, at peaks, pressure is usually low. So partial pressure of oxygen present in air is also very less. So due to that, its solubility, we know P is directly proportional to X. When partial pressure decreases, mole fraction also decreases. So its solubility in blood decreases. So due to decrease in the amount of oxygen in blood and tissues, it causes a medical condition known as anoxia. Due to anoxia, person becomes weak and he becomes unable to think. So in order to avoid this anoxia also, those people carry oxygen tanks or air tanks along with them. So this is the third application. At higher altitudes, at high peaks, partial pressure of oxygen is less because the pressure is less. Due to that, partial pressure of oxygen also decreases. Due to this, what happens? The concentration of oxygen in blood decreases. Concentration means solubility of oxygen in blood decreases. Due to that, in our blood or in tissues, the amount of oxygen decreases. And due to this, what happens? That person becomes unable to think and he becomes weak, and that serious medical condition is known as anoxia. This can be avoided by carrying oxygen tanks or air tanks along with them. The next one. After this, we are going to study the second effect on solubility of gases in liquid, that is effect of temperature. How temperature affects solubility? We know dissolution of gas in liquid is always an exothermic process. That means delta H is negative. Temperature of the system increases. When you dissolve a gas in liquid, what happens? Delta H, that becomes negative, or temperature of the system increases. The process is exothermic. Now what happens when you increase the temperature? When you increase the temperature, according to Le-Chatelier, when you increase the temperature, what happens to solubility? Solubility of gas in liquid decreases. So here gas plus solvent gives you a solution, and this process is exothermic. This process is exothermic. Dissolution is exothermic. When you increase the temperature, this solution system tries to decrease the temperature. When you increase the temperature of this system tries to decrease the temperature. You know what is Le-Chatelier's principle. So now when system tries to decrease the temperature, backward process is favored. That means dissolution decreases, or solubility of gas in liquid decreases. So this is about the effect of temperature.